Well, hi there, boys and girls. I just want to give an idea today of what extrema are, and I also want to be able to find them from a picture and also how to calculate them using calculus. So we're going to start off with the fact that there's two different kinds of extrema, and those are absolute extrema and relative or local extrema. And we've got a little, this is very definition-y here, but we're going to talk about absolute and global maximums first. An absolute maximum is the highest point on the graph. You can see here that f of c is taller than or bigger than every other point on f of x. So if you have a point that's taller than every other point, we can call that the absolute maximum. Now the absolute minimum would be if you have a point that's the absolute lowest. So you can see this y value here is smaller than every other point, then that's an absolute minimum. So you're looking at the whole picture there. Now those are only going to be on closed intervals. Excuse me, I'm sorry. Okay, now relative extrema or relative maximums happen in some little interval around x equals c. And so you're going to look just a little to the left and right. And you're going to see if you have a point that's relatively or locally taller than every other point around it, we'll call it a relative maximum. And then a relative minimum if that point is lower than all the other points in that area. Let me go show you what I'm talking about. Pictures are much, much better. So here we have a graph. At A, this point is the absolute minimum because there's no other point on this entire curve in this interval that is lower than that. At D, we have an absolute maximum because there's no other point on the graph that's higher than that. So you locate those on the closed interval first. And by the way, every continuous function will always have an absolute maximum and an absolute minimum. That's going to be an existence theorem we're going to see in a little bit. But those will always be the case if you are in a closed interval for a continuous function. Now let's go take a look at these other relatives. Here is a relative maximum. In this area, in this little area, it's like a high point. And so we're going to call that a relative maximum. It's higher than all other points relatively, or relative to this position. Here is a relative minimum because around in this interval, that's the lowest point. Now let's take a look at this one right here. This point is not a relative minimum or a relative maximum. It's just that this function is decreasing all the way through here because in this interval there's some points lower and there's some points higher. And then over here on this endpoint, endpoints cannot be relative extrema. Endpoints cannot be relative extrema. So I would not label this point at E as a relative minimum. But they can be absolute minimums. And that's why this one is absolute but not relative. Okay, let's go take a look at another example. Here's a picture of f of x equals x squared on the interval from -1 to 2. Now let's find an absolute minimum. That's pretty easy. This point right here is an absolute minimum because there's no other point lower than that. So I'm going to say that's at 0, 0. Okay, out here at 2, 4, this is an absolute maximum. It is not a relative maximum, however, because it's at an endpoint. That's our endpoint is at 2. So absolute maximum at 2, 4. This is nothing. It's not a relative maximum. It is an endpoint, but it didn't end up being either relative or absolute for max and mins. Let's take a look at another picture. How about f of x equals x squared on -2, 2? Well, here I've got 2 points that are competing with each other. I've got -2, 4, and I've got 2, 4. And those y values are exactly the same. And so a function can have 2 points that have the exact same absolute maximum. So I would say this graph has an absolute maximum of 4. That's the biggest value. And it happens at 2 places. X equals -2 and x equals 2. So you could say that both 2, 4 and -2, 4 are absolute maximums. But you would probably say that the maximum is 4. It just happens at 2 different places. This graph also has an absolute minimum down here at 0, 0. This is an absolute minimum. This graph has no critical, I'm sorry, I can't say that yet because this graph has no relative maximums, but it also has a relative minimum. This is in the interior of the interval, so the absolute minimum can also be a relative minimum, because in this interval there's no other point that's lower. Alright, so we're going to have something called an existence theorem. This basically says if you have a continuous function on a closed interval, there is always an absolute max and min. Always an absolute max and min if it's continuous on a closed interval. So if you have to go find them and you know it's continuous, then you know for a fact they're out there. They might happen at endpoints, but they could also happen in between, and that's where we're going to have to use calculus to figure this out. This is called an existence theorem. So this is just saying if a function is continuous on a closed interval, will it have a maximum? Well, yes, it will, because of the EVT. If a function is continuous on a closed interval, will it have an absolute minimum? Yes, it will, because of the EVT. All right, we're going to also define what's called a critical point. This is what I almost said earlier. A critical point is going to be potential extrema. Now, if a graph has a relative max or min, it has to happen at a critical point. Relative max and mins have to happen at critical points. And these are points where a graph slope is 0 or the graph does not exist. I'm sorry, the slope does not exist. So in other words, if I have this our little V graph, that's a horrible V, Mr. G. I'm so sorry about that. But still, this is an absolute minimum and a relative minimum, and it happens where f prime does not exist. And earlier I had some slopes that were 0. Like right here, the slope was 0 and it ended up being absolute min or in relative min. Here I had a slope of 0, absolute minimum. Here I had a slope of 0, relative minimum. Slope of, I think that was going to be undefined. Let's go see if that was a sharp turn. Yeah, that was a sharp turn. So at that point, f prime does not exist, but it still was a critical point. Here I've got f prime as 0. Here I had f prime as 0, but it didn't work out to be a relative max or min because it kept decreasing. I'll show you how to tell the difference later. All right, so let's work a question. But before we do this, this is how we're going to find absolute extremum. You're going to have to verify it's continuous. Then you're going to find all critical points, because you could find a place where the graph turned around and had a slope of 0, and if that's the case, that's a potential max or min. And then we're going to look at that function and we're going to identify. Let me show you how we're going to organize all of this stuff. I've got a closed interval from -4 to 2. The first thing we're going to look at is this continuous. Is this continuous? Well, yes, it is, because it is a polynomial, and all polynomials are continuous everywhere. Yes, it is a polynomial. Therefore, the EVT guarantees that we will have a relative max and a relative, absolute max, and we will also have an absolute minimum. These are going to have to be things we answer. Now, we could also, they don't have to occur at the endpoints, but they could also occur where f prime equals 0. So that's what we're going to start with. Well, here we're going to have g prime equals 0. I'm full of mistakes today. All right, so I'm going to find g prime of t, and that's going to be 6t squared plus 6t minus 12. And we're going to set this equal to 0, because if a graph has a relative max or min, it has to at least be 0 there. So this equals 0, and we factor out a 6. And we go ahead and factor this thing. That's going to be t plus 2, t minus 1. Okay, so we set this equal to 0. Where does that equal 0? That equals 0 at -2, and that also equals 0 at 1. So what we're going to do, we know that the slope is 0 at these points. So we also know that these are critical points. That's the definition of a critical point. The derivative is undefined or the derivative is 0. They could be max and mins. So here's what I'm going to do. I'm going to look at our closed interval, -4 and 2. So I'm going to make a little table. I'm going to have t, and I'm going to have g of t. I'm definitely looking at my endpoints. So I look at -4 and 2. You always have to check endpoints. I realize that had nothing to do with our derivative equals 0, but absolute maximums can occur at endpoints. But I also want to check these critical points. So let's go back up and see what g was. If we plug in -4 for g, what do we get? So I'm going to have 2 times -4 cubed plus 3 times -4 squared minus 12 times -4 plus 4. And we're going to plug all that in. Let's see what that would be. -4 cubed is -64. And then -4 squared is positive 16. And then plus 48, and then plus 4. I sure hope I did that correctly. Let me erase a little bit here so I can finish this math. Let's do purple. Finish in purple. Okay, so that's going to be -128 plus 48 plus 48 plus 4 is plus 52. So this is -28. That's what g of -4 is. Let's do the same thing for -2. 2 times -2 cubed plus 3 times -2 squared minus 12 times -2 plus 4. -2 cubed is -8 times 2 is -16. -2 squared is 4 times 3 is 12. Plus 24 plus 4. So that's 3640, so that looks like we are at 24. Now if we plug in 1, that's going to be a little easier. Plugging in 1 is 2 plus 3 is 5, minus 12 is -7, plus 4 is -3. And then if we plug in 2, so we'll go ahead and write this down. What do we get? So we're going to get 8 times 2, which is 16. 4 times 2 is 12. Minus 24 plus 4. So I've got 32 minus 24, I'm at 8. So let's take a look at these y values. What was the smallest y value here? Well, I have -28, I have 24, I have -3, and I have 8. The smallest y value was -28, and it happened at an endpoint. So the absolute maximum, absolute minimum is -28, and I can even give that an ordered pair, -4, -28. Now, what was the biggest number we saw here? Well, the biggest number we saw here was 24, and that happened in the interior. That happened at a critical point. So the absolute maximum was 24, and I could probably go ahead and give that an ordered pair as well, -2, 24. So we got an absolute minimum that was at an endpoint, but then an absolute maximum that occurred at a critical point. So this is what you guys are going to have to do tomorrow, and I will see you then.